Hello, everybody. Thank you for joining us. We're just going to give it a minute as people continue to join the webinar. Hello, everybody. Thank you for joining us today. My name is Jake Williams, and I'm the manager of K through 12 and Young Professional Programs at the AIAA headquarters office. Some of you may have many years of experience with AIAA. For others, this may be your first time attending one of our events. So whether you're just starting to launch your career in aerospace or if you're looking for a new career path, AIAA is really an amazing resource, and we have a lot of content to help you on that journey. So one thing I wanted to put in the chat here, and I see a question. Yes, we are recording this webinar so folks can go back and rewatch it later. So don't worry about that. In the chat, I'm putting a few resources for folks to be aware of that I just wanted to mention. One is to check out our AIAA Career Center for hundreds of open job postings, including full-time and internship opportunities. You can also build your network by getting involved with your local section or student branch. A lot of people have been asking about AIAA forums. Our next ones are coming up in July in Las Vegas, which is a great opportunity to meet a lot of people in the field, and especially build your network at Meet the Employer events. You can also enhance your knowledge with leading industry publications and continuing education courses and workshops that are available online. And lastly, if you have any questions about this or anything else that AIAA has to offer, don't hesitate to reach out. My email is in the chat, jakew@AIAA, jakew@AIAA.org. So don't hesitate to reach out. As we're going along on this webinar, feel free to use the chat box to ask questions. We will hold off until after the speakers to kind of go into the questions, but feel free to use that as you go if anything comes up that you'd like to ask them. I am now happy to introduce our host for today. Ari Jain is a fourth-year PhD student studying aerospace engineering at Georgia Tech in the Bin-T-Zin combustion lab, where he focuses on lean, pre-mixed, pre-vaporized combustion and sustainable aviation fuels. He received his bachelor's and master's in aerospace engineering from the University of Illinois at Urbana-Champaign. And Ari serves as the Georgia Tech Aerospace Engineering Graduate Student Association Vice President and the AIAA Region 2 Deputy Director for Young Professionals. Thank you, Ari. Take it away.
Thanks, Jake. And thank you, everyone that's joining us. Good morning, good evening, based on whatever time zone you're in. I think Jake covered it, so we'll just get right into it. We have three amazing engineers joining us from various different companies in the United States. And we're going to each give them about 10 minutes to talk about their careers, and then 30 minutes overall at the end for a general discussion and questions. So I'll get started with our first speaker, who is Josh. Josh works in the Flight Operations Directorate at NASA's Johnson Space Center, where he serves as a certified flight controller, instructor, and astronaut trainer for the International Space Station. He also supports operational development for NASA's Artemis lunar missions. Josh holds a bachelor's in mechanical engineering and a master's in aerospace engineering. And before joining NASA, Josh gained broad private industry experience at Tesla.
Awesome. Thank you, Ari, and great to be here. I always love to chat with folks who are looking to diversify their careers and kind of explore their careers. So I'll jump into that a little bit today. Let me know if you can see my screen okay.
Yep, all good.
All right. Yeah, so my name is Josh. I currently work at Johnson Space Center in flight operations. I'll talk a little bit about NASA as a whole and then where I fit into NASA, but also a little bit about how I landed where I am. And I'm sure we'll talk more throughout the course of the panel about some more of those details, but just high level. So NASA really does to kind of just explain how much NASA does. This is one of the better visuals for just how spread out NASA is. You know, a lot of people know about some of the uh, more well-known field centers like Johnson, Houston, we have a problem, or Cape Canaveral launching rockets. But there are over a dozen NASA field centers across the country, and they just do all kinds of stuff that you may or may not know about. So I really just wanted to start off by talking about NASA as a whole and highlighting um, the fact that there is something for anybody to do here, whether it be, you know, space flight operations or aircraft research, interplanetary robotic exploration, launch vehicles, propulsion. The list just goes on and on. Psychology, medicine. There's something for everybody in human spaceflight. And so I just wanted to say that before I jump into my specific niche is no matter what you're interested in, NASA is probably worth looking at for that. But like I mentioned, I work specifically at Johnson Space Center in Houston, Texas. And inside of Johnson Space Center, I work in the Flight Operations Directorate. So Flight Operations is tasked with planning, training, and flying the nation's human spaceflight priorities and programs. And the Flight Operations Directorate goes all the way back to the origins of human spaceflight and NASA. So you can see in the flight operations emblem along the bottom, the different programs that FOD, as we call it, has supported, from Mercury, Gemini, Apollo, Skylab, Shuttle, and we are currently flying ISS, Commercial Crew, and Artemis. And so operations is near and dear to my heart, and I think my path to operations was unexpected. A lot of folks will go to engineering school, right, and you learn a lot of the design or analysis or like the highly technical engineering skills. And me personally, and I think a lot of people I knew aspired to, you know, be design engineers and make a thing. And I was convinced that, you know, early in my career, as I was looking at what I wanted to do, that I wanted to go make things. And ultimately, I started out my career with some different internships at Tesla, then Tesla Motors. And I started out there in operations, but with a mind to get into design. And I just had that first taste of operations, and I was absolutely hooked. I like to say operations is sort of where the rubber meets the road. And so it was a career arc that I was not expecting, but that completely changed my life. And I'm loving operations and specifically flight operations at NASA. So I'll talk a little bit about what flight operations does. Really, the crux of it, it comes down to what I have here, which is plan, train, fly. That is our mantra. And we plan, train, and fly for really any time the US is sending people into space. So on the planning front, planning covers a very long period of time, right? It starts with initial mission planning and refining mission sequences, right? Like something like this graphic here of high level, what are we going to do and how are we going to do it? How and when do we leave Earth? When do we make burns? When do we depart for the surface? Like the high level mission sequencing, but really the Flight Operations Directorate takes those higher level mission plans and breaks them down into something that we and the astronauts can actually execute. So we write flight procedures for the crew, detailed flight procedures. We construct detailed crew timelines. Timelines are typically scheduled down to the 5-minute mark. They're incredibly detailed. And we really also integrate across all players. And this has always been true, even back to the first international cooperations in space, like Apollo, Soyuz, or Mir space station. But even more and more as time goes on, we are integrating across more and more players. The International Space Station is integrating across international partners, commercial providers, um, you know, private astronauts coming up on Axiom crews, coming up again here soon. We're integrating across more and more players, and this only gets bigger and bigger in Artemis, where we have many components, right? Like the SLS rocket, Orion spacecraft, human landing system, both from SpaceX, Blue Origin, the Gateway. We are integrating more and more components. And at the end of the day, like I said, the rubber hits the road with operations. And we need to pick apart the details of how these things work, how these people talk together to really accomplish a mission. So I think the planning aspect of the Flight Operations Directorate is really covers quite a lot and is pretty special. The next thing we do is train. So we're training our own flight controllers, but also selecting, training, and protecting the crew. So I just kind of sprinkled in some photos here of what that might look like. Here in Houston, we have two pretty iconic buildings. The one on the left is the Space Vehicle Mock-up Facility. So that's me with the crew of Crew 4. I was the training lead for maintenance for Crew 4. And behind us, you see a life-size mock-up of the International Space Station, where we really run them through the procedures and day in the life of living on the space station. The Flight Operations Director runs the Neutral Buoyancy Lab. You probably mostly see the Neutral Buoyancy Lab in videos of astronauts diving underwater in spacesuits to test things in neutral buoyancy, where they weigh themselves out to perfectly float in the water and mimic zero gravity. So in the Neutral Buoyancy Lab, there is another mock-up, life-size mock-up of the space station underwater where they can go practice spacewalks. But we also practice stuff on the surface of the Neutral Buoyancy Lab, including things like water egress from a capsule, say, that has splashed down. So here's me with some of my team members kind of running through some water egress procedures. And then the part that's, I think people know FOD, Flight Operations Director, the best for is the flight, of course. The classic phrase, Houston, we've had a problem. When there is a problem, it is Flight Operations Directorate who answers the call. So I arrived at NASA in 2019, and I certified, I think by about 2022, to be a flight controller for the International Space Station. So this is me at what we call the OSO console. OSO stands for Operations Support Officer. We are responsible for all of the mechanisms and maintenance aboard the International Space Station. So as well as the habitability on board the space station, we enable humans to live and work in space. So if it breaks, we fix it. Flight and flight control is really, I do training and planning as well, but flight control is really what pulled me into operations, because operations, in my perspective, is pretty unique. In operations, you are the product. At the end of the day, what the Flight Operations Directorate provides is certified flight controllers to execute the mission. And so when you are training to be a flight controller, you are training to better yourself as a person, to better your communication skills, to better how you function under pressure. It is your job to show up to work each day and become better. So I think that is the allure to me of operations, as well as just the fact of being the tip of the spear and where the rubber meets the road. You get a lot of diversity in like the things that you get to experience and the hardware that you get to touch. You get to talk to experts for just about anything, in my case, for ISS, just about anything on the ISS that you could imagine. You can reach out to the experts, to the subject matter experts, and learn and execute. And every day is different. So that is really what I look for in a job and in a career, is for that, for every day to be different and to be learning something new. So that is my pitch. I will now pass it on to the next speaker.
Thanks, Josh. I don't see any quick questions in the chat, so we'll keep moving to Robert. Robert is a senior staff member at Johns Hopkins Applied Physics Laboratory in Maryland. He works on advanced propulsion systems such as rotating detonation engines, hypersonics, and rocket propulsion. He received his master's and PhD in aerospace engineering at the University of Central Florida and previously worked there as a postdoc scientist as well. Robert has lectured undergraduate air-breathing propulsion courses and currently still mentors aerospace and mechanical engineering students. Outside of this, he is the AIAA Deputy Director of Education for Region 1. Take it away, Robert.
Thanks, sorry for the introduction. Okay, so I can just get a confirmation from any of the panelists that the slides are showing up.
Yep, all good.
Sweet, thank you. All right, yeah, thanks very much, Ari, for the introduction. So I'm Robert Burke. I'll talk a little bit about APL. I won't go into too many details, especially about the day-to-day job, because I imagine that's probably what a lot of your questions are going to be about. So maybe we can save that for the question part. And then also talk a little bit about myself as well. But as just a very brief overview, APL stands for Applied Physics Lab, but really the full name is the Johns Hopkins University Applied Physics Lab. We are associated with Johns Hopkins University. As I show here in one of the bullets, APL is a scientific and engineering and research and development division of Johns Hopkins. So we are a part of it. We do have the JHU part of our email address, and we are .edu. But one of the really important things about Johns Hopkins is that we are considered a trusted agent and trusted advisor for the Department of Defense, NASA, and also a lot of the other government agencies. So we're kind of straddling that line between industry as well as also government. So APL, first started back in 1942 during World War II. It started under the Office of Scientific Research and Development, Section T. However, after World War II had ended, the U.S. government just saw a lot of capabilities and a lot of importance to APL. So at the government's request, it continued on after the war. A fun fact that I actually didn't know until I started working here was that if you're familiar with James Van Allen, he's a very famous astrophysicist. He actually worked at APL back during World War II and afterwards. So interesting fact. But APL is also considered a university-affiliated research center, or UARC for short. So essentially, we're a not-for-profit organization. And again, that helps us fill that role as a trusted agent for DoD and a lot of other government agencies. We work with pretty much the full gamut of DoD, so anywhere between the Navy versus Air and Air Force, also some other agencies like MDA, the Missile Defense Agency, Department of Homeland Security, DARPA. Pretty much anyone who has any work to do with the government, we've had some part in it. So a little bit about us. We are the largest UARC out of all of the affiliated research centers here in the U.S. With about, I think the current count is 800 plus total staff across 600 plus programs that we work with the government and also with industry. Our main campus is here in Laurel, Maryland. So we have a nice proximity to DC and the capital. But there's also a lot of satellite offices that we have nationally that are typically engaging directly with sponsors or with the government. In terms of what we do at APL, a lot of our operations fit under the 4 sectors and 2 tech departments and the 13 different mission areas that I have here on the slide. So in terms of the sectors, just kind of running down the list, we have the air and missile defense sector, asymmetric operations, force projection, space exploration. And then we have 2 tech departments, being the National Security Analysis Department and Research Exploratory Development Department. So some of those are a little self-explanatory in terms of their titles, but as you can see, we have a very wide spread of expertise that we have here. So if you think air and missile defense, so we have an entire sector that's devoted towards, the United States' air and missile defense capabilities. Asymmetric operations is where you're essentially taking all of the different types of knowledge bases, and also, things like your intelligence, surveillance, reconnaissance, and putting that all together to make informed decisions for the warfighter and also for U.S. government. Force projection, which is the sector that I'm in. We're kind of the antithesis of air missile defense, so we're looking more at the offensive capabilities that we have. Space exploration is thankfully self-explanatory there, and we do a lot of work with NASA. National security analysis is a little bit similar to asymmetric operations, but it's a little bit more of under the hood decisions and operations. And research and exploratory development is, a very big part of APL, given that we are a research center. There's an entire sector, technical department, that really falls under just pushing the advancements across the board of what we can do and what kind of technology that we can develop for the country. Now, all those fit under different mission areas, and there's 13 that are listed here. I'm not necessarily going to run down the entire list. If you have any questions about them, please feel free to ask more. But this is essentially where the programs feed in, and we essentially divvy them up between the mission areas. And for example, I am a part of Precision Strike. It's about midway through the list. So it's a part of force projection, but we're specifically looking at, the aerospace side. So we're looking more at the flight vehicles on the side of force projection. So just a little bit of a summary. We have what we consider defining innovations as a part of APL. These are essentially some of the big milestones and contributions that APL has made for the U.S. and kind of going throughout history. So again, I'll just provide a little bit of a summary for each of these innovations. But of course, if anyone has any questions, please feel free to provide more. So at the advent of World War II, our initial involvement at APL was with the radio proximity fuse, otherwise also known as the VT fuse. This was essentially a capability where you have your air-launched projectiles that would come out of a gun launcher. Essentially, it was a small fuse where, as it gets close to an aircraft, it would then explode the round. That was a very significant and very impactful contribution to the war. However, though, as we continued on after that, another innovation is our surface-to-air missiles. In terms of some of the first ramjet missile systems that were developed, like Talos, those were done here at APL. If we continue down the list, transit. This is where we essentially merged GPS tracking with submarine capabilities. So as you can also see, besides air stuff, APL also does a lot in the water and with the Navy. AMFAR being Navy phased array radar. This is essentially if you can track multiple targets with radar, which was kind of an issue in the past, but was a problem that APL was able to contribute to. Advanced sonar array is a bit self-explanatory, but more again helping out the warfighters in the sea. SATRAC, which is really looking at the Trident missile defense system in terms of being able to better gauge performance. Especially during Trident missile testing and such. You don't necessarily want to rely on your performance models when you actually have a threat right there in your face. So it's a good idea to make sure that everything is going to work exactly how you want it to. I'm sure operations, Josh, I'm sure you understand where I'm coming from. Tomahawk, APL still has a very significant hands in Tomahawk, but at least with the initial guidance and navigation systems, APL was the one that had really kind of spun that up. Cooperative engagement capabilities, as we have more and more that we're doing outside of the U.S. borders in terms of ships, aircraft, and even satellites and such, can we keep all of those together in order to better inform what is in the air and what is in the sea? So really having everyone work together to get an understanding of what the kind of the field looks like. Low-cost planetary exploration. I believe this is in reference to the NEAR satellite, which I believe did a very close flyby to the asteroid Eros, but it was done for a fraction of a price than some of the previous satellite programs that had been done. So more of a proof of concept that, you know, we can do some pretty big things in space for relatively low cost. And then ballistic missile defense from the sea. This is where essentially we've taken a lot of our defense systems that are more at the homeland, and we're starting to put them out and extend our borders further and further. And then planetary defense, this is where we're looking at DART. This was a recent mission, and if you're not familiar with it, it was essentially a satellite that would essentially fly right into an asteroid in order to try and push it off course. So this is on the planetary defense side. It was a success, and DART was something that was a very big effort from APL. So just a little bit about me. I'm an aerospace engineer, and in terms of my background at APL, I've actually only been at APL since the very beginning of 2024, so I'm coming about a year and a half now. Specifically, as I mentioned, I'm a part of the force projection sector, part of the precision strike mission area. Specifically within that, I'm a part of the vehicle design group, and I work on the propulsion work for a vehicle design, where we're essentially looking at advanced vehicle concepts. Besides that, though, I think Ari had mentioned this in the intro, I'm the Region 1 or the Mid-Atlantic Deputy Director for Education for AIAA. So while I'm mentioning that, I'll also add a little shameless plug. If you are in Region 1 or the Mid-Atlantic area, so kind of around Maryland, New York, you can look it up on AIAA's website. We do have a student conference at University of Maryland that's going to be next March in 2026. So if you have any questions about that, please feel free to reach out to me, and I can provide some information. But it's a fantastic conference. If any of you have been to AIAA SciTech, it's like a lower stakes version of SciTech, but you also get to meet a lot of other young professionals and students that are kind of around the same age, but also a lot of industry folks go to these conferences in order to, you know, solicit open positions and such to get all the great talent at their companies. My background before APL was at University of Central Florida, postdoc scientist for 2 years, where I was specifically working with detonations, like rotating detonation engines and also hypersonics. And then, of course, my academics, Ari had mentioned before. Another thing I'd like to also mention outside of work, I very much enjoy hiking and traveling, which I would like to mention is a concern that I think some students and young professionals get into when they get into their career, especially if they get into something that's a bit more classified or secure. Just know it is still possible to do personal travel. It is not something you just kind of wipe off your capabilities. So I do want to give you all that nice little bit of information. And then also, I really love showing this off. This was some stuff that I'd done in my graduate degree. So the bottom right image is an image of a rotating detonation engine that we had test fired in a collaboration with the Air Force Research Laboratory. It's one of my prouder images that I've taken of testing. So I'll keep it short on that. And Ari, I'll go ahead and pass it on to the next panelist.
Thanks, Robert. There are many questions in the chat that have started populating, but I'm just going to hold off until the end. So keep them flowing, guys. That's totally fine. But just realize we will not, we'll address them all at the end. You can use the chat or the Q&A. I'll monitor both. So last but not least, we have Chris, who is the technical assistant within the office of the Chief Technology Officer of the Lockheed Martin Corporation. Prior to this role, Chris served as both the space and aeronautics business areas of Lockheed Martin, including within the advanced development programs Skunkworks. Chris specializes in conceptual design, systems architecture, and test, working on programs from hybrid airships to hypersonics. He holds a bachelor's and master's in aerospace engineering with a specialization in multidisciplinary design, analysis, and optimization from the University of Michigan. Take it away, Chris.
Cool. Yeah, thank you, Ari. I appreciate it. And yeah, I'll try to keep it short here as well. And if anyone has questions during it, feel free to put them in the chat. And then after this, I'll try to type in some answers too, because we might not be able to get to everything that's coming through in the chat. But I'll keep it short here. Just going to focus on the day in the life of an engineer, really at Lockheed, but more specifically in the hypersonics domain, which is something that Robert obviously talked about as well. So we'll step right into it here. And first, I'll give an overview of what Lockheed is. There's lots of different business areas. Just like Robert mentioned with John Hopkins APL, they do lots of different things. We also do lots of different things. So the day in the life of an engineer really at our company depends on which of these divisions that you're in. I won't go over everything that's listed in here. We'll just say that I've worked in both the aeronautics and the space division. But fortunately, right now in my position at corporate in the Chief Technology Office, the Office of the CTO, I've had a chance to work with all these different business areas and see different products and technologies that they use. So happy to kind of take any questions across that. But I will just say that, the day in the life really depends on what phase of the life cycle you're in and what actual program you were working here. Working in the ADP Skunkworks in the fast-paced division might be very, very different than working on a CH-53 helicopter, for example, that's been in service for 50 years or more. So I just want to give that quick background. One more item here, just to show an example of a very diverse set of platforms that we have that are meeting our customers' mission. I pretty much know colleagues that have worked all these different types of platforms, just sort of why I pulled these together. And the main reason I wanted to put the slide in here is because, this right here is why I chose aerospace. It is such a diverse ecosystem of products. We do everything from your classical fighter jets, obviously hypersonics, which is what I worked on in the upper right-hand corner. But we also do lasers. We work with our partners at NASA, for example, on OSIRIS-REx asteroid samplers. We certainly do satellites as well, but we even do applications of AI at the edge. That's actually shown there in the lower left-hand corner. We're looking at autonomous ground robots in the battlefield of the future. So really, why I chose aerospace is because of all these different platforms. And why I stay with aerospace is because it feels like every week there's something new to kind of talk on and work with. So that's kind of what quote unquote gets me up and working every single day. I figured that I would give a quick background on myself too, just so folks know. I actually grew up in the Valley Forge area here in Philadelphia. Quickly went over to Michigan to get my bachelor's and master's, like Ari had mentioned. My focus there was in aerospace engineering and specifically multidisciplinary design. I did some internships. I was really, really fortunate to have some internships that were really critical to shaping my career. I had some not great ones that I didn't enjoy, but I learned from them. I learned kind of what I wanted to do. And really, my career arc has just been trying different days in the life of an engineer every single year or so until I found the day in the life that I really liked the best, right? So after that, I came to California to work for Lockheed full-time. I mostly worked hypersonics there. That was really my bread and butter, my domain. And that's kind of where I kind of chose the day in the life that I wanted to live. I then actually came back, though, to the East Coast, to where I'm from. I work in the Lockheed Valley Forge office here, still doing hypersonic technology specifically in our research and development portfolio. I've actually had the pleasure of working with a lot of colleagues just from Robert down at APL and across the industry. And then I will say in the meantime, I do have a life as well. I work with AIAA and partner on what's called our Aerospace Robotics competition. I'm a council officer in our local Greater Philadelphia section, and I also do other things in my life as well. So I do have a balanced lifestyle, but I also really have a passion for what I do. So specifically, I want to give this intro to hypersonics because that's really what it's a big calling for me. It's what I do now, and it's a hot topic right now. So I won't brief all of this, but hypersonics, really fast, Mach 5 or greater, very much characterized by interesting aerodynamic properties, free molecular flow, not a continuum, and also very, very high temperature environments. But why do we need them from a mission standpoint? We need them for responsiveness, we need them for survivability, and we need them also for defending against other really advanced threats that are coming out there. And there's a lot in the news right now that you can read more, but that was just kind of a high-level take on the importance of hypersonics. And really, this graph says it really well. How far does hypersonics get you in 30 minutes, right? You can get from Washington, D.C. to Memphis here on an F-30 on a commercial jet. You can get to Cleveland on a commercial jet as well about the same time. You can get all the way to Wichita from Washington on SR-71, which is great. But you can literally get to Micronesia on a hypersonic vehicle, right? Now, are we going to be flying hypersonic vehicles anytime soon? Probably not. But this just kind of gives a picture of what is that kind of time scale and how fast are these vehicles going and why it's such an important investment area from our government, but also in the commercial sector as well. And then finally, I just wanted to wrap it up here with a little bit more details of what the day in the life is. If you focus on hypersonics, there's lots of different challenges. I kind of chose 5 here. And based on what challenge you're working on here, your life may be very different. So let's take innovative materials, for example. I worked that for a very long time, both from the concept phase of coming up with these new materials to the coupon phase where we were doing coupon tests in the lab, all the way to the point where we were doing arc jet tests and flight tests. So some weeks I would be out, flight testing, doing really, really exciting stuff there. Other weeks I'm at my desk in the lab. So the day in the life does really change. It's more, but then there's some jobs that you are, more doing analysis. If you're doing the heat analysis, for example, the thermal analysis. So it really does change based on all of these. And like I said before, the key for me was having lots of different internship experiences and then just different experiences in my full-time career that I got to choose the day in the life that fit me best, which was a really life that, does a lot of testing, a lot of new technology. I'm in the lab, quite a bit. But I'm also at my desk quite a bit too, working on what's going to be the next generation of technology. So I tried to keep it very quick. I know we're a little bit behind schedule. So Ari, I'll pass it back to you for any questions and answers that we got now.
Sure. Thanks, Chris. And thank you all for getting the ball rolling on questions. Robert has answered some in the chat already. I'm going to do my best to get through as many of them as possible. I will leave my contact information right now in the chat as well. If you have any questions that I didn't address, send them to me. I will send them to our panelists and we will get an answer to you. But I think one kind of broad theme that has come through with all the questions is what opportunities at your companies do you have for high school students, undergraduates, and graduate students, people and kind of all those at those 3 different stages?
Yeah, I can go first. I mentioned internships is something, and even co-ops as well, that we certainly offer. I was both an undergraduate intern and a graduate intern at my company. And then we also have co-op positions as well. So those are really kind of broad. And they aren't just reserved for, upperclassmen, so to speak. We have interns from across the gamut. In fact, my first internship was very much not an aerospace type thing. It was like a quality or manufacturing intern, which was a great experience, right? Not something I quite wanted to do, but I still learned a lot, even if it wasn't an aerospace engineering internship. So I always recommend to YPs and especially students to keep your mind open to other opportunities because you never know what you're going to learn.
I'll go ahead and go next. Similarly to what Chris had mentioned, we also have some other opportunities here. One thing I'd like to stress about APL is that we're essentially trying to get as much talent in as many different specialties and expertise as possible. You never know what the government or what industry will come to us in terms of what problems or what solutions they'll need. So in terms of actual opportunities that are available, for high school students, we have the Aspire program that typically starts during the summer, but it also kind of could continue out throughout the rest of the year. That's specifically for high school students, so they can apply and they can essentially do an internship here at APL. We also have more traditional, more conventional internships for undergrads. A lot of the positions that really actually come are more on the postgraduates. So after you've graduated with your bachelor's and or also graduate programs. But again, there are certainly positions that open up. If you just look at Johns Hopkins APL career opportunities, again, most of these start during the summer, but a lot of those can continue on to more opportunities throughout the rest of the year. But one thing I'd like to stress, and Chris kind of touched on this, is that especially as a young professional or student, this is the opportunity where you really get to cast a wide net, take advantage of opportunities, take advantage of the time where you really get to put yourself out there and try out new things. There's a lot of experience and a lot of knowledge you can get by just saying, hey, I'm a student, or hey, I'm an undergrad and I just want to learn something. You'd be surprised how many people out there, how many companies and engineers will give you a bunch of their time and telling you about what, what their job is, and even just tell you about the technical details just because you're interested and, you're engaged. So definitely now is the time to be looking at internships. Josh, I'll pass it on to you.
Yeah, I just wanted to start by wholeheartedly agreeing with both Chris and Robert that experimentation, especially as early as possible, is absolutely what you want to be doing. Learn what you like and what you don't like and take risks. Because like me, I was not pursuing operations, and it was by taking a risk in something I didn't think I wanted to do that I found my calling. So with getting involved with NASA specifically, I think probably one of the bigger challenges, to be honest, is there's so many different ways it's hard to pick apart and find all of them. So, I mean, NASA is involved with high school and college research organizations. For internships, there's the NASA Pathways program. But I also really like to highlight for people that NASA is a nationwide team that comprises of NASA civil servants, but also a huge contractor workforce, and other companies that support NASA through contracts. And so for me, the pathway into NASA actually was looking through the contractors. And I was kind of unaware of how much NASA work gets done through contractors, and that I should be applying to more than just NASA.gov. So it can be a little bit hard to find those contractor points of contact if you don't know where to look, but I happen to know where Johnson Space Centers is, so I'll post a link in the chat. But generally, NASA is a government agency, and who NASA is working with contractor-wise is pretty widely known. So I would highly encourage, if you're interested in doing work for NASA, to both be applying at NASA, but also with some of the contractors.
Awesome. Thank you, guys. I think that addressed that question. If you guys have any specifics, again, like I said, send an email to me, and Robert put his email in the chat as well to follow up. Another kind of broad question there. It seems like there's a good amount of international students in the chat, in the call. Breaking into aerospace in the United States as an international student can be tough. So what opportunities do you guys have at your companies, or do you have colleagues and friends that have gone through that struggle and maybe made it to the other side, and how have they navigated that? I'll go Chris first again.
Yeah, sure. I mean, this was definitely a challenge for Lockheed, obviously, just because a lot of what we do is kind of on the classified side. But I will say, I should have put the slide in there, but if you look at our international footprint, it's huge. We have labs and offices across the globe. Especially in the past 2 years, I've had the great pleasure of working with lots of folks from Australia, the UK, different parts of Europe, and actually even the Middle East as well. We have field offices in the Middle East. Typically, those folks are actually at those offices, right, rather than in the U.S. But there's exceptions. Obviously, there's always exceptions to in these scenarios. So they are limited, but they are there. But I will say, they certainly are at least limited at a company like Lockheed, fortunately.
All right, I'll go next, just to keep the same order. I think that go on Chris. There really aren't very many opportunities. I would have to say we do have the entire research and exploratory development section, which a lot of that is kind of on the cusp of between unclassified versus then more classified work. So there could be some opportunities there. What I would suggest though is that still reach out, and this is kind of a blanket statement, not even just for APL, but also for other companies or organizations. It never hurts to reach out and find out what opportunities there are, because it always can be a case-by-case basis. Otherwise, at least some advice that I've gotten from some peers that I have that started out as international students and have since transitioned to other jobs. A lot of times they've taken this opportunity to go into higher levels of education, whether it means master's or PhD programs. This could be the time to just continue developing on your skills as you kind of naturally start to find what your interests are. And then usually at that point, you can kind of work your way in and find a position that opens up. So there are some opportunities at APL, but I would suggest certainly reaching out to us directly. Feel free to reach out to me directly, and we can see if there are any opportunities available.
Yeah, from the NASA side, I think space flight is inherently, in my opinion, an international endeavor now. And on the NASA side, you can definitely still get involved with NASA work, NASA grants, NASA research through universities. I can't necessarily speak, as I don't know anyone personally who has, I don't have coworkers who have come from internationally, but space flight is, there are space flight organizations and agencies around the world. So in flight operations, we are working regularly with the European Space Agency, with United Arab Emirates, with JAXA over in Japan, right? There are, space flight is an international endeavor, so I would highly encourage getting involved with any space flight agencies or organizations where you live. But I also know several people whose countries don't yet have a space flight presence, but they are using that as an opportunity to blaze the trail and try to advocate for space flight in their own communities and countries. So that is also an option as well that I would encourage.
All right, thank you guys. I'm going to switch gears a little bit and ask different types of questions as well. Thank you guys for answering questions in the chat simultaneously too. But all of you have graduate degrees. What do you think the value of a graduate degree is in terms of doing it right after your bachelor's, or maybe going to work for a couple of years and then coming back to getting your master's and even your PhD?
I can go first on this one as well. It's a good question. Everybody's different. There is no one size fits all. Like, if you want to be an engineer that is, purely designing, building, testing hardware, you don't really need a master's for that, right? You learn that in undergrad. You can do that. If you have aspirations of kind of the research end of it, right, needing a little bit of higher education, that's where you kind of want the master's, right? Or on the flip side of it, if you have aspirations being engineering management, there's engineering management masters, right? So there's different options out there for folks. Me personally, I wanted to be kind of a technologist or a researcher. So I purposely chose to get that master's right away in a highly technical field. So I didn't do it at night and all that. I just did it, focused. And then I went out into my career and used it. But I have lots of peers who, they got an engineering management master's, a little less technical, but obviously still focused on engineering. And now they're kind of leaders, like people leaders in the company, right? Engineering organization leaders. So it kind of depends on what you, and if you don't know what you want to be yet, right? Then just wait, get the bachelor's, go work a little bit, figure it out, and you can always go back, right? There's a time window where it's easy to go back. And then a lot of times the company, if you're with a private company, they will help pay for it in some part. So that's kind of how I would frame it.
Yes, I would agree with Chris. If it's something where you already have an idea on the technical work that you want to do and the subject and everything, graduate school can help get you better knowledge of that, and also could open up some doors in terms of when you are looking for that job that you're looking for. However, though, I would also like to echo what Chris mentioned. If it's something where you're on the fence, I would suggest go right into industry, go right into job seeking, because that's really where you're going to get a feel for what it is you'll be doing. So that's where you'll realize, okay, maybe I actually don't really want to do this job. Then you can take a step back, and a graduate degree can help. One thing that I would say, some people say, it's hard to get back to school after you've been working a job for 5 or 10 years or whatever. Honestly, sure, maybe it's a case by case basis, but I would say based on most people I know, they've been easily able to get back into doing school after having a long time in industry. The main thing that you just have to budget is your time, because oftentimes when you go back to school, it's not just going back to school 100%. You're still working part-time or even full-time on your job. So it just means balancing your life a bit. So it just means maybe a year or two where you get less sleep than usual, but it's certainly possible and shouldn't discourage you from trying to jump right into grad school. You can still do it later down the line.
Yeah, once again, great answers by both Chris and Robert. I definitely agree. Everybody's different. For me, I did my undergraduate. I worked for a while, and I went back to grad school when I felt it made sense for me. But different people are in different situations, different circumstances, and what makes sense for you. You must just have to listen to yourself, and what feels right.
Awesome. Next one I'm gonna ask is, when you guys started, I guess you guys may have kind of addressed this in bouncing around your different roles and finding what works for you. But when you started in your current roles, what did you imagine your role would be like, and how does it actually compare? Or I guess you may have experienced that in the various roles you've had, but how does your perception of the role when you start and what actually happens after the first month of onboarding, how does that compare?
I don't want to be fair and take it first again, but I can if you want, Robert and Josh. The only thing I'll say is that there's almost like an imposter syndrome. That's the biggest thing I felt like right away. Is I felt like I'm going to go into the job and it's going to be super serious, right? Everyone's going to be super smart, super serious, and everything like that. And in reality, they're all just people. They're making mistakes too, and they're learning, and they're doing it because they have fun. And I think that was the biggest lesson I learned right away, is to remember it's a learning experience, not take it too seriously, and really kind of enjoy the journey as opposed to just kind of having your sights in the end. So maybe it's kind of a weird response. So I think it's important for YPs, because sometimes YPs are I remember being very intimidated by, those folks in the industry, the folks in NASA, at the labs and stuff like that. But in reality, once you get there, everyone's people, everyone's willing to help you out. It's a very collaborative environment, right? And that was kind of eye-opening to me. So I thought I would share that kind of less technical anecdote.
Yes, yeah. Everyone starts out as a young professional. And honestly, especially being an engineer, when you get into whatever position, you might be working side by side with, people that have 20, 30 years of experience on you. But honestly, everyone becomes an engineer for relatively the same reasons. And it's very easy to find those shared interests and shared things between everyone. So, you could be geeking out with someone about Star Wars, and again, they could have been at your job for 30 years longer than you, but everyone is kind of all in the same, we're all trying to do the same thing. And again, just like to emphasize that we all started out as young professionals. So, just get in there and, just make the most out of the job that you can.
Yeah, expectations versus reality wise. I think honestly, flight operations has been pretty close for me. The one maybe unexpected thing that maybe should have been expected given government work and international government work is there is quite a lot of paperwork and some bureaucracy and churn associated with some of this stuff that is kind of part of the job as well. But it's all in the spirit of doing the right thing and getting the job done. So yeah, I love it all nonetheless.
Okay, we have 4 minutes left. I think the question I was going to ask was, what do you guys recommend? What's your advice to the next generation of aerospace engineers? But I feel like you've hit that broadly throughout these questions. So I think I'll conclude with instead, what are you guys excited about for the future of aerospace engineering? And what do you think is next as a field moving forward? I'll go Josh first this time.
Sorry, I was typing a response in the chat. Do you mind repeating that one more time?
What are you most excited about for the future of aerospace engineering moving forward as a field?
Yeah, for me, and again, I'm speaking from the spaceflight perspective, it is just this increasingly broad number of players and accessibility of space. I think the opportunities in human spaceflight, space exploration in general are just growing pretty exponentially. There's opportunity everywhere. So I'm really excited, with all of these new capabilities and opportunities, what people will do when unleashed on the problem of human spaceflight. I think there's just so much potential, and everyone on this call is going to be the ones who are executing that and bringing us into the future.
Okay, I'll go in the middle again. I'm very biased in terms of propulsions and propulsions research. So I think it's very exciting because it seems like there are a lot of advancements in propulsion technology, even over just the past decade. So I'm really excited because I think that there is probably going to be a pretty big revolution in terms of capabilities we can do. And I won't go into too many details, but I would just say that, in my opinion, I think now is the time to be involved in propulsion work. So that's what I'm excited about.
Yeah, Robert, since you said propulsion, I'll say something else. I'll say 3 things. I'll say AI, biotech, and quantum. No particular order, but there's lots of different ways we could apply AI in aerospace now to help offload some of the work that the human is doing. It's very, very interesting. And then quantum and biotech as well I view as emerging technology fields that are kind of ready to have the question asked, how do we apply it to the aerospace industry? So I'll keep my response short with that.
All right, so I think this is Jake. We're at 11 to be respectful of everyone's time. We can kind of wrap it up. I assume the transcript of the chat, Jake, will also be saved. If I can go through and kind of filter the questions afterwards and send them to our panelists. And you guys can pick and choose which to respond. And I don't know if there's a way for us to distribute it to panel attendees or not. So sorry we couldn't answer everything. I think I tried to hit the bigger questions that everyone had. But thank you again all for joining us. Thank you to the panelists for taking the time this morning. And if there's nothing else, Jake?
Yeah, thank you, Ari. Thank you, the 3 panelists and everyone for joining us today. Really appreciate it. I know we have a number of high school students on here today, so if you are interested, for all you high school AIAA student members, tomorrow at 8 p.m. Eastern Time, we have a virtual meet and greet with members of the Electric Propulsion Technical Committee. I just put that link in the chat. So as we're talking about some interesting innovations in propulsion, the last couple minutes here, if you're available, be sure to join us for that. And other than that, thank you all for joining us. Really, really appreciate your time. We'll have the recording and follow-up questions posted to sent to all the folks who registered and also on the website on the landing page. Thanks, everybody.
Thank you.
Thanks, everyone. Have a good day.